So I will start, I guess, as usually second day of the conference. Not everyone survived the party, but I'm still happy that you came. I'm really pleased because I was not expecting so many people. In any case, harnessing the power of Materialized Views in Cosmos DB. What I will be talking about today, I want to give a little introduction on the Cosmos DB itself because I'm not sure how many people actually work to this. But in any case, I'm sure it's going to be interesting to listen once again, even if you work to this on a daily basis. I will talk about Materialized View approach. I will show a little bit of code how to implement Materialized Views with Azure functions. And I will also say a couple of words about actual built-in feature that is currently in preview for Azure Cosmos DB. But before I will start, I will say a couple of words about myself. So my name is Olena Borzenko. There is a QR code if you want to connect on Twitter. I will talk for a few more seconds so you have time to scan it if you want. But in general, I'm a software developer. Currently, I'm working as a software consultant. My main stack of technologies is C#.NET. I did a lot of front-end in the past. And lately, last few years, I'm working mostly with the cloud technologies and Azure. So I'm also Microsoft MVP. This year is actually second year. I'm really happy that I was renewed. And I'm also international public speaker, so this is not my first conference. Last year, for the first time, I attended code.talks. I really liked it, so I'm really pleased that the team invited me once again to speak. And I'm also organizing events by myself. I'm a part of the admin team for Global Azure. So if anyone is interested to speak at the event related to Azure and know about Global Azure, please submit every year. We're really pleased to have people willing to share the knowledge. So I'm working in a company called Xspirit, Xspirit. So we specialize in cloud, security, GitHub, and of course, the software development. So now let's go to the actual presentation. I will make a little introduction to Azure Cosmos DB. First of all, what is actually Azure Cosmos DB? It's not just a database, it's a platform as a service. So as you can see on the picture, on the diagram, there is a lot of details. I highlighted here the most important ones. So Azure Cosmos DB has multiple APIs, the table API, Cassandra, SQL, MongoDB, and Gremlin, and I'm pretty sure that there is another one was added. By default, when you create an Azure Cosmos DB, it will be NoSQL, SQL API. You can also have the multiple levels of consistency. Azure Cosmos DB is the only one that has 5 different levels of consistency. So it's gone from strong one, default one is the session consistency, there is eventual, and there is two in between. I always forget the name, so sorry for this. But in essence, it's a globally distributed, multimodal, as already mentioned, document-based database. So no matter how you want to store your data, no matter how you want to operate it, it's going to be always a document. What it actually means global distribution? I mean, words itself are pretty self-explanatory. It's probably something that is all over the world. But let's have a look at a bit more details what it means actually for the user, for us, for the developers, and in general for the system. So when we have a browser and we're making a request to the application, the first thing that is catching our request is the Azure Traffic Manager, if we build the system in this way, of course. Azure Traffic Manager takes care of the request and redirects it to the right region, to the Azure region. Because database and application, when it's globally distributed, it means that it will be as close as possible to the user. Not only the application itself, but also data will be placed in the data service in our region. So we have, for example, West Europe and East Europe, and it means that there's going to be 2 different data centers. They will have the replicas of our data. The same about application. So when the Azure Traffic Manager receives our request and it knows, for example, that I'm from Berlin, it will redirect my request to the specific Azure region. Afterwards, of course, receiving a request that we want to get some data from the database, the specific, Azure Cosmos DB is globally distributed between regions. It means that it will go to a specific region, to a specific replica, and extract the data. When we're talking about global distribution and replication data for Azure Cosmos DB, depends on the consistency level, there is going to be different amount of replicas. So by default, there is 3 replicas that Azure Cosmos DB has. But when you have cross-region distribution and a strong consistency, the Cosmos DB will have the 4 replicas, and one will be responsible for copying data from one region to another. Of course, this is the most expensive setup, and this is the most expensive operations that you can have. But if you really need a strong consistency, if you have a healthcare system or financial transactions, you might want to have a strong consistency. You don't want to eventually get the numbers on your bank account or something like this. You want to have them immediately. So talking about elements in Azure Cosmos DB, as I said, it's a platform as a service. This is not just a normal regular database. So there are some terms, some words that we need to know and understand when we want to work with Azure Cosmos DB. So this is, of course, I didn't create this diagram by myself. I took it from the documentation, but I will just say a couple of words what it actually means. So when we create a database account, when we create an Azure Cosmos DB account, on our subscription level, we create account, and in this account, we have to select the consistency levels because it's shared for the account. The API is also shared for the account. And then we can go deeper to the database level. So one account can have multiple databases. Every database will have the same API that is the whole account. You cannot select Gremlin and MongoDB and SQL under the same account for the same Azure Cosmos DB. When you created a database, going deeper, you can have the container. So there are different names. Some people call it container, some people call it collections, but in general, it's kind of a namespaces for your documents. So it depends on what you create there. You can have actual items stored in your container. You can have storage procedures. You can have all your triggers and conflicts, resolutions, and user-defined functions. So all the things, they are stored within the container because they are specific to a certain type of data, to a certain set of data. Depending on the Cosmos API, the container will be representing different items. So as I already said, it might be collection, it might be table, it might be graph, and etc., etc. So for Gremlin API, for example, it will be graphs. For items, what is related to the items in the container, when you have the multiple documents stored in there, so all those documents, again, depends on the API that you're using. They will be either called documents or the node or edge or actual row. So for table API, it's going to be row. For the Gremlin, it's going to be a node. So this is very important to understand the difference between all those words, because when you're reading documentation, for example, for MongoDB, even if you worked before with SQL API, you will be reading the same things, but you will think that it's a completely different story, which is not true. So just knowing that it's the same collection, might be called graph or might be called table, really simplifies your life. So going a bit deeper, what is partitioning in Azure Cosmos DB? When you create a container, the first thing you have to do is specify the name of your container, and you have to provide partition key. This is for MongoDB, again, I'm trying to bring as many examples as I can during my session. For SQL API, it will be partition key, but for MongoDB, for Mongo API, it will be sharding key. So they talk about partitioning for the MongoDB as a sharding strategy. In essence, that means the same thing. You just have to provide a property in your document that will be the path to the property in your document that will be picked up, and this value will be used for the abstract aggregation or grouping of your items, of your documents. So on a database level, you create 2 different containers. For example, you want to store user information. For one container, you select the partition key path called name. So if you have ID of a user, ID of a document is always a unique and you cannot repeat this number. You cannot change this, this value. You cannot change this value. You cannot duplicate this value. An ID of the document is ID of actual document and not your entity. If you want to have a separate ID that is responsible for actual data you store in, you can have as a separate field, or you can say that your ID will be the same as a document ID to use it for more efficient querying. So when you have the partition key pass name, what it means that when you have a user information ID, name, first name, last name, address, etc., your documents will be grouped by the name. So if my name is Olena and I have a document in the user container that represents my details, the detailed information about me, but also some shorter information about, for example, the overview for some web page, for example, my picture, my name, and my position. Both of those documents will be stored in the same container with my name as a partition key, which means when you will want to make a request to this container and say, give me all the documents that has name Olena, it will know which partition key to tackle, and it will select all the documents from this partition and select those documents. It will return those documents to you. At the same time, you might have a case when you want to filter your data by age, for example. You want to select all the users that are older or younger than 20 years, for example. You do the same thing, but you take your data, you duplicate your data, you aggregate it, and you store it in a different container next to your main container, and you just transform your data in a different way. So the information that will be stored there is still the same information. The only difference there is that, for example, the partition key will be age, and there will be age 20 years, for example, and you will have the list of all the users that are less or more or just 20 years old. For every age, for every year, you will have a separate document, but let's be honest, it might be maybe around 100, maybe 120 documents at all. So if you want to have that kind of a separation and you have not many users, that's a good strategy. But if you're working with the really millions and millions of records, that might be not the best approach, because if your document grows too big and more than 1 kilobyte, the operation of querying or editing this document will also increase in cost. So we have multiple items in one container and a second container. This will be called logical partition. It's got either logical partition or it's a sharding. It's depends on the API, as already mentioned. So one logical partition, which is just abstract group of items, as I already mentioned before, the ID of every document has to be unique. The partition key value can be the same for multiple documents. It means that it will just select multiple documents when you are when you're querying a container with a specific partition key. But if you want, for example, to have a point read operation, what point read means is that you spend only one request unit to query your data. You can combine your partition key and ID of the document. You can make it the same value. So your partition strategy will be ID of the document. And when you want to access the user information, for example, you can use the user ID for this. It will be, if it's 1 kilobyte of data, the document is not more than this, you will have always one request unit. Why it's important to think about partition strategy, why it's important to actually spend time to model your data in a correct way. Now I'm coming a bit closer to what is actually materialized views and why do we want to pre-aggregate or transform our data. This lowest row, the physical partitions, is the main reason. The thing is that our logical partitions, those groups of items, one group will be always stored on the same physical machine. So if you have your group of documents for name Olena, for example, all my documents will be always on the same machine, in the same data center. However, it doesn't mean that documents related to any one of you, even if it's from the same collection, that they will be stored on the same data, in the same data center, in the same physical machine. As you can see, those arrows, they indicate that this is really possible, that group A or B or C will be placed on the different centers. Why is this happening? Because of the size of the collection. So size of one collection can be 20 gigabytes. And of course, there are different numbers. And of course, you can contact the team. You can explain your use case. And Azure Cosmos DB team, they can change those values. Like they might increase for you value the size of one collection. But this is the standard. And if there are a lot of data stored in one data center and there is no more space, your logical partition from the same collection might be moved to another data center. Which means if you would say, select for me all the users that have name Olena and, for example, Yuri, you will go first to the one data center and then you will go to another data center. This is called cross-partition querying. Cross-partition query is extremely expensive operation. I mean, in general, materialized view approach is targeted to avoid that kind of queries. As I'm talking about cost and request units, I just want to highlight what it actually means, the request unit, just for those people who didn't see it before, don't know about it. The request unit is just a measure of computation cost. It's how much memory, how much CPU, and how many IOPS operations you're doing. So one request, as already mentioned, one read operation for the file that is 1 kilobyte, or not more than 1 kilobyte, it will be always one request unit for read. If you want to write a document, update a document that is less than 1 kilobyte, it will be no less than 5 request units. And just to give you a feeling what it means, 1 or 5 request units, you can individually set a provisioning for each container. What means the provisioning is how many simultaneous calls you can do, or not how many simultaneous calls, how many request units can be accepted per second. So if you have one request unit, your operation is one request unit, and the minimum value is usually at least 400 request units, it means that in 1 second you can do 400 operations per second. If you want to write, then you have 400 divided by 5 is going to be, I believe, 20. I'm not sure. Okay, math is not my strongest thing here. So anyway, you got the logic, right? So you divide 400 by 5 or 1,000 request units by 5. Yeah, I know it's morning. Please, I see that some people are laughing. So the point is that this is the maximum accepted amount of request units of load per second that your container or database can accept. There are different modes. So there is the auto-scaling or scheduling scaling of your container, of your database. So if you say, for example, in the morning, there is a much less load on the system than in the evening, you can schedule your scaling option. And in the morning, there will be provision throughput. But in the evening, it will become an auto-scale. And the moment when the requests start coming in, database will automatically increase the throughput. It might be dangerous for those who don't know how to work with Cosmos DB, because if you set automatic scaling, having a hope that everything's going to be all right, and then all of a sudden the maybe loop happened, maybe there is some kind of a dependency of one document, of one trigger on another, you might spend all your money on because of this mistake, because Cosmos DB is not the cheapest solution, but it's a very powerful solution. So, talking about Cosmos DB and built-in features, there is something called change feed. The change feed is I very often hear the saying that it's event sourcing out of the box. So change feed is basically a history of all your inserts, of all your updates in a Cosmos DB. Wherever you write a document, wherever you update the document, this operation will be stored separately in change feed. This is not something you can switch off or on. This is done automatically by default for us. And you can use it or you can completely ignore it. The Azure Cosmos DB allows you to implement event sourcing by yourself. But if you're looking in some kind of a persistent data store, persistent record store of your records and changes, change feed will do this for you. And there is multiple ways how you can actually interact with this data. So wherever you made the change or wrote something in Cosmos DB, it will be stored in change feed. You can use a pull model, which is one of the most complicated models, because you have to connect to the specific partition, to connect to the specific data center, to machine, they handle all the exceptions, handle all the errors, deploy by itself this your application. But this is a great way to go if you want to just one time extract all the data and move it to a different data source, for example. So this is called pull model. Another thing which is called push model. There's these three ways altogether from what I know. So there is a pull model. The push model will be when you will implement change feed processor. You can use Cosmos DB SDK and have your implementation, which is much simpler. It's basically an abstraction on top of this pull model. You provide the connection string to what database you want to connect, what container you want to listen, but most of the operations are done for you by SDK. So you will just have to, of course, deploy it and still maintain it, but this is much easier way. And the easiest way, as you can see here, is the Azure function. So Azure function is the same push model, but we only write our logic, and Azure is taking care of managing all our resources. So for example, if I will be later on showing the code that will be example of the warehouse system, if I want to react on every change that is happening in my warehouse system, every time when someone will pick up the item, will scan the item, I will use the Azure function for this because this is the easiest way. It is a very quick operation. You scan a barcode, you put the data in the Cosmos DB. What else you can do afterwards? You can use the same Azure functions, for example, to calculate the stock and the state of your warehouse. I'm sharing this experience of the warehouse system because some of you might know a company called Durst Express or maybe Flash and Post. So current warehouse system of them, there was a time, maybe 2 years ago, when I was building architecture. So architecture is more or less, I mean, this is a very simplified way, but that's basically how it works. We write some data in Cosmos DB the moment when the picker, the employee in the warehouse scans the item. And those Azure functions, they have triggers on a certain containers. They will react on this, this movement insert, and will generate the stock information and the state of the warehouse. This allowed us to know where are the items and if we have enough items in the house. So integration with other Azure services. Of course, if it's an Azure service, there's many other services, and they are sometimes like Lego bricks. You can combine them in different way for different purposes. For example, as I already said, you can use Azure function. You can use Event Hub if you want to have like event computing or notifications that something changed. But if you want to do heavy calculations, for example, you can use something like for stream processing. You can use Apache Spark, for example. In our case, we had a use case that we want to have a real-time suggestions. So if you buy the item and you live in my district and now someone else buying similar item or the same item, because I bought something different in the past, for you, the system will suggest that people nearby also interested in those products. Or that kind of use cases. So doing this with Azure Cosmos DB is possible, but probably a bit too expensive that you want to spend on the database. But Apache Spark connects to the nodes, to the replicas of Cosmos DB under the hood, and can do all this real-time data processing for you. You can also have data movement, so basically zero downtime migration of your data to another data store. You can use a table, or a blob storage, or another Cosmos DB, if you want. It's very often the case that building a system, you have a requirement. What if we will need to move to different database? Well, not a problem. You can connect to the change feed, pull all your data, and put it wherever you want. So, materialized views. All the things that I explained about Cosmos DB, and what I explained about cross-partition querying, and the cost and everything, this brings us to the materialized view approach. Why do we want this? Why are we interested about it? Because as I already mentioned, Cosmos DB is not cheap. Also, we don't want to have cross-partition querying. So what we do, the Cosmos DB is really cheap for storing data. It's like 50 cents per gigabyte, I guess. That's the numbers I remember. So if you want to have a different views, different aggregations for your data, what you do is duplicate it. So materialized view in general is the just pre-computed data set derived from the query specification and stored for later use. So this allows us to have a faster querying. As I already said, you can take the user information and you can create a different views. You can create the overview and the dashboard of a user. You can create a detailed view of the page. You can create all the likes of this user or all the favorite products, but they will be related to the same user. So you will have somewhere all this information stored to the same, related to the same person. But when you want to show this aggregation, you will pre-calculate, you will pre-aggregate this data, and you will store it for later use. This approach is basically means that you are making your write operations more expensive, but read operations much easier and faster. So when materialized views are useful, when the query results contains a small number of rows and columns. So if you want to have an aggregation, if you want to have an overview, if you want to have the short list of items with just a few fields, you just copy those few fields. You don't need to copy all the information. When you want to have the query results that are after significant processing, after significant calculations, semi-structured data, or the aggregations that take a really long time, you set this process in the background. The moment when the calculation is finished, it's pre-saved for you. And when you want to read it, instead of executing your query again and again and again, you will just have to read the data that is already there exists. And views-based table does not change frequently. So if you really don't want, like, there might be a question like, what happening if we want to change our original data? Well, if you want to change this data and you really think that it will still bring you value, having a materialized view, having pre-aggregated data stored somewhere, do it. But it might be the case that you have much more often write operation to your data rather than read. In this case, materialized view would not be the best way for you, because every time you want to read something, every time there is insert happening, you will have to change all the related materialized views, which will result in a really, really expensive write operation. But if you query it once per something, this just doesn't make any sense. Can we wait 2 minutes? Okay, great. So the benefits using Azure Cosmos DB for NoSQL materialized view, really just a few points. So it's a reduction in cross-partition queries. As I already said, if we have a case that we want to query different groups of documents, we might want to have a materialized view, but if we have way too often updates, that might be not the best case. Reduction in RU changes for the existing queries. So again, we already pre-saved, pre-aggregated queries, and we can just request the data anytime we need it. Improvement in query and execution time, because there is no execution of a query. We calculate it one time, we store it, and then we update it if we need it, if there is update happening, but actual execution of the query is done one time. Zero coding effort, which is kind of true, but also not exactly. You can have if you use materialized view built-in feature for Cosmos DB, you just have the JSON file where you provide what fields and where you want to copy. However, if you want to use the Azure functions, you will need to write a bit of a code for this. So easy tuning and monitoring of materialized view containers. Of course, you have all the logging, all the details in Azure, because it's another Azure service that is fully managed for us. So I will show just really quickly, because I mentioned before that I have the Azure function implementation. As I was already bringing the case with the warehouse system, this is the function that I had to store an actual movement in a database. So you see the Azure function name. Sorry, this is the name, create movement. And there is a couple of triggers and bindings we are using here to operate with our data. So HTTP trigger is just like a normal REST endpoint. You call it, there is a post action, you provide a body. For example, there is a movement happen of this article, I moved it from point A to point B. What is happening afterwards? I'm using a binding. There is two types of bindings you can use, and there is many bindings can be used in one function. However, only one trigger per function is allowed. So there is an input binding and output binding. Input binding means that your data will be loaded in the container on the start of execution of Azure function. The output binding means that the moment when the Azure function finished execution, your data will be stored to a database automatically. So we got our data, and what we do, I'm just iterating on like creating multiple tasks. I'm creating a single movement. This method just generates some random data, and let's have a look. So it just generates some random data, and this documents out. I'm just adding every item that I generated before to the collection. This document out is, as I already said, this is an output binding. So the moment when I added all my items to this collection, I don't need to say save as sync. I don't need to save my data. I don't need to say anything. I just need to add it to the collection, my items. The moment when my Azure function finished execution, it will be automatically saved to Azure Cosmos DB. So I saved my movements, and then what I can do is to react on this change. There is a database, and depends on what version of Azure Functions and SDK you're using, that might be either container name or collection name. I provide that I want to connect to the warehouse system, and I want to listen to every change in the movements container. So when the change is happening, what I want to do is to handle my movement change. I do the same thing. I aggregate my data, I calculate the things, and I do the same things. As you can see, I have a tasks, and every task will save storage, will save a stock information and the state of the warehouse back. So this is just the principle for you to see how it works. But what I was saying before, the zero coding effort, well, it's not exactly zero, but you can agree that it's not that much. Of course, the business logic will take a few lines to code or to write how you actually want to aggregate your data. But this is the comfort that we have using Azure Functions with bindings and triggers. All this connection to the database, all this connection to the what container you want to use, what connection string, what actual database, is all managed by SDKs, by Azure Functions, and so on. We just need to click publish, and our functions will be running in Azure. And if you did everything right, you will have your write and read operations ready for you. So, as I also mentioned before, yeah, there was a demo. As I also mentioned before, there is a way to enable Materialized View feature on a Cosmos DB. We're already running a bit out of time, so I will just show this JSON file. If you worked ever with Azure CLI, this will not be so weird and unfamiliar for you. If you never worked with this, so this is just the command line for Azure. You can write a command, you can give some parameters, and this will be basically like infrastructure as a code. You can write a code for your infrastructure. So you can execute some commands and create some resources on Azure. This is exactly what this JSON file has. So normally, if you want to create automatically a Cosmos DB and some containers, you will have the same file except Materialized View definition section. So this file, this JSON file is telling that you have to create certain resource in a certain region with the certain partition path. This Materialized View definition tells you what source collection you want to use to aggregate your data. So take your user collection, select from the user collection ID and username, and store it in the user by name or whatever other collection. So that's basically all. There is a CLI, Azure CLI command. You take this file as a parameter, so you execute the command using this file. And again, if you like enough, you did everything right, you will get this resource, you will get a Materialized View on your container. So I will wrap up now the presentation. Just a few limitations. This is related to actual built-in feature Materialized View. There are more, and you will have this presentation if you want to get a closer read, but I highlighted just those that I think really important. If you want to work with this, you have to remember that where clause in the Materialized View definition is not yet supported. So if you want to say select this field and this where user age, for example, is less or more than 20 or whatever else, this is not supported yet. You cannot write actual query. The Materialized View definition, aliases are not supported for properties of items. So you cannot remap the name of the properties. It's the way you store them, the same way you will read them. Role-based access control is currently not supported. Another very important information, because role-based access control is something it's built in Azure Cosmos, but not for Materialized Views. This is not yet there. And cross-tenant customer-managed key-based encryption is not supported on Materialized Views. Encryption is very important, especially when we're talking about data, exchange of data, and data exfiltration and other risks. So encryption is not yet there. So yeah, this is the end of my presentation. Thank you very much for coming this early to my session. And now it's the time for questions. But once again, thanks everyone. And I wish the great rest of the conference. Thank you.